Multiplying and dividing positive numbers. This is really just checking that you do know all these strategies, so I will go through them quite quickly. If you're not sure on these algorithms, let me know and I'll help out. And if you're a little shaky on multiplication of your 12 times and up to 12 times table, maybe watch the core video. Really quickly, what the core students are learning is how to use this grid. You'll have this for your work and for the test, so you can check any of your 12 or up to 12 times tables. To multiply with the grid, 3 times 7, so find them on the outside row and column and work out where they line up. It's 21. It's useful to use a ruler. To divide, it's a little bit opposite. For the second number, go to its column, so in the top row, find it, and scroll down until you find the first number, 48, go across to the left, and that's 8. I should put some answers in. So 3 times 7 was 21, 48 divided by 6 was 8, and you can use this to check if you're not sure in a test, because sometimes we panic and forget our times tables. So just making sure that you know how to use this. If it didn't make sense, watch the core video. Reminding you about some mental strategies for doing tricky multiplications. Rearranging, remember that you can multiply in any order. So this is much easier, or could be easier, if you did 5 times 2 is 10, times 6 is 60. Doubling and halving, if you can easily get one of the numbers to be something easy like 10 or 2, then we can make opposite changes to each of the numbers. So 5 times 160 is a bit tricky to do, but if I double the 5 I get 10. Half of 160 is 80, half of 16 is 8 and I've got a 0, and 10 times 80 is 800. So it's interesting to be able to spot where it's easier to do some of these little manipulations. But of course, if we were stuck on that, we could use the multiplication algorithm. The distributive law is splitting up the multiplication or distributing it, sharing it among different parts. 7 times 89 looks like we should really have to do it with a calculator or an algorithm. But that's pretty close to 7 times 90. So what we could do is do 7 times 90 minus 7 times 1. Remember, you can work out 7 times 90 by doing 7 times 9. And if you're stuck, 7 times 9 is 63. So 7 times 90 would be 630. Take away one lot of 7. So it was only 89 lots of 7. So what did we got to? We got 630. That would be 623. So there's all these little strategies. If the distributive law didn't make a huge amount of sense to you as to how I split up, let's have 90 lots of 7 and take away one lot of 7, then feel free to check in with me and we can go over it. The division and multiplication algorithms you should know, but we might need to go over them. If you're absolutely confident that you could do this, maybe stop at the moment, do it, and skip to the end and see if you got the same answer as me. And if you did, you know you don't need to watch this bit. If you didn't, you need to do it. So, unlike adding and subtracting, for our multiplication algorithm, we line everything up with the smallest digit over here. Sometimes that'll mean units line up with units, sometimes it won't. We start at the bottom right. So we're going to do this number times all of these, and then this number times all of these, line by line. Again, you should know this, so I'm not going really deep into it. It's just checking that you remember the strategies. So 5 times 2 is 10, and when I get a number that's bigger than 9, I've got to put down the units and carry the 1 to somewhere where I'll remember to add it, but not make that 11 or something silly. 5 times 1 is 5. Sorry, someone at the door. 5 times 1 is 5, plus 1 is 6. Remember, we're not dealing with this yet. If you prefer to put that little 1 up there as a reminder, that's okay, just don't go thinking this is 11. 5 times 4 is 20, and we'd put down the 0, but because there's nothing else to be dealt with here, we'd also put down our 2. Now that was multiplying everything on the top row by 5. We've now got to multiply everything on the top row by 20, because it's 5 and 20. This is actually just like the distributive law. We're splitting it up and doing our multiplication separately and then combining it. And to save multiplying everything by 20, which is really difficult, because I know that's the same as multiplying by 2 and putting a 0 on the end, I'll just start by putting my 0 on the end. So now I can go 2 times 2 is 4. And that makes sense because this was 20, I did the 5, I've got 20 left, and 20 times 2 is 40. Now I'm doing 2 times 1 is 2, and that's really 20 times 10, which is 200. So I've got a total of 240 there to go, and 2 times 4 is 8. Now in the same way as with the distributive law, we worked out the first bit and we worked out the second bit and we combined it. We do that here. We can combine these to get the total of when we multiplied by 5 and when we multiplied by 20. 0 plus 0. 6 plus 4 is 10. We put down a 0 and carry the 1. 1 plus 0 plus 2 is 3. 2 plus 8 is 10. And so I've got quite a large number here. So that's the the multiplication algorithm. Algorithms, you remember, are a method of doing something. And division, you should remember that you set it up with the division algorithm, the number that we're splitting up underneath, divided by 13. And we might have to get a little bit tricky. I should have picked an easier one for you. But we're doing extension, so hey. 13 into 9 doesn't go. So we'll look at 93. 13 into 93. Now you can use this for a bit of help. Even though it doesn't go up to 13, you can have a look. If we had 12, 12 would go into 96 8 times. So chances are, it's, because 13's bigger, a little bit less than that. So you might try the 7. You might have to wander off over to the side and do very quietly 13 lots of 7. 7 times 3 is 21. 7 times 1 is 7, 8, 9, 91. Good, it goes in. So we might have to do some little quiet bits of working off to the side to work out that 13 goes into 93 7 times. With how many remainder? 2 remainder. You pop that in there. 13 into 28. Well, that's fairly easy. 1 lot of 13. Yep, for sure. 2 lots of 13 would be 26. So it would go in twice. And at the moment, we're just going to list the remainder. We've got 26, there's 2 left over, remainder 2. We'll learn how to deal with the remainders more mathematically later, you might also know that. But all that is just going through a couple of the strategies that we should remember that we might want to use in this topic.